Yeah. Okay. Good afternoon. So in this morning lecture, we just got to introduce to the course, and we have looked at the overview of the content of the course, not in very detail, but just we were browsing through. We were just comprehending how are we going to go about learning this course. And it is more of having some interest development towards this course. That's what we were doing in the morning session. Along with that, we were looked at the syllabus copy, syllabus content, and then two prescribed textbooks. Then we were looking at some other sources. There are many sources for this vehicle crashworthiness subject. But it is so much abandoned, though it is of 2 decades content, more popular in last 2-3 decades only. But it is now given more due importance in all developing and developing countries like India, our country. So our country, this crashworthiness, we had started focused very recently, not even 3-4 years back. Only it started. It was supposed to start in 2014. That's called the New Car Assessment Program, which was very long back in 19th century itself. In US, they started very first New Car Assessment Program, whereas like India, like our country, which is the 10th country that chose to start such a crashworthiness evaluation program, which is recently 2017 only. It is had its first thought and then started developing. Still, the establishment for such kind of new car assessment program is not completed in its sense. It is in a developing stage. So if you see that the study of this course is very vital, that's what we understood. We will be at least getting our understanding, learning with respect to the content abstracts given in the syllabus copy. That is what we were seeing. And additionally, we also have got clearly understood what is the assessment scheme for our theory component. So you have midterm test and you have FAT exam and internal another 30 marks or 1 DA and 2 quizzes, and those dates were discussed. So as I have told and concluded in morning lecture, now we will have some more of introduction only today also of our course, and to have an idea of what all the segments that we are going to focus on learning in our course. And at the end of this lecture, we will have an idea of J component, how are you going to go about, and the important dates for meeting the J component assessment, which is of another 1 single credit. So this course is of 3 credit course that you are aware, right? So let me just share my presentation and then go to the lecture, and then we'll have discussion on J component. Everyone is able to see the screen. This is lecture number 2, vehicle crashworthiness. The introduction class for our course, as we were seeing this crashworthiness, when you say it is all because of safety aspects that has to be brought in your vehicle. And as now the safety is given more importance like any other vehicle requirement, like what we have learned in vehicle dynamics course, performance, handling, ride aspects. So this vehicle crashworthiness also is given a metric due rank on par with everything, as it is going to ensure the vehicle development with its most required safety aspects. So it doesn't mean that vehicle does not have the safety aspects. Vehicle do have, but this kind of crashworthiness focused dynamics would help us to look at how it is important for product development. So with that understanding, let us just look at what are the safety aspects that go in our vehicle crashworthiness, and which has been mandated by importantly federal motor vehicle safety standards. So in this slide, you could witness in a given sedan class passenger car, what are the different aspects that go into provide vehicle crashworthiness, and what do you mean by frontal impact? So you could see this arrow. So the front portion of your vehicle would be given an impact over a rigid barrier or deformable barrier. In such cases, what would happen to the vehicle integrity, especially vehicle cabin integrity? So it has to allow, like in the morning we have defined, the crashworthiness is defined as the vehicle capability to plastically deform in the impact location and to protect the cavity of your vehicle, cabin cavity of a vehicle, so that the occupant with type of restraint would be safeguarded. So that is what is the definition of crashworthiness. So you could see frontal impact, there are regulations number FMVS 201, 204, like that it's written. So you can see on the right the details of these codes. 201, it is more of a standard for occupant protection and interior impact. So this would have been tested with the dummies present, and dummies are hitting on inside the cabin. Then how it has been. So more of passive safety measures which are there in a vehicle may be looked at through this standard. And you see 202A, that is for head restraints, and 208 is frontal impact occupant protection. So most of the time you see this is that most of the focused crashworthiness evaluation procedure as this is a common compared to the other kind of collision. This is commonly occurring, occurrence of this collision is more. And you see there are FMVSS 214 is for side impact occupant protection. So this safety standards would tell what would be your vehicle design aspects. So these standards, when you see, these standards are mandated because of that vehicle is developed, and the development has got the required design aspects, required vehicle accessory present in the vehicle. So for example, you see frontal impact to account, you have a bumper. So the bumper design should be such that the intrusion of your the energy during frontal impact should be taken more in the frontal zone of the bumper, and that has to be dissipated as the deformation expected is crumbling. So that's it's a plastic deformation. So the energy is not going to be more, and that energy is what is the rebound energy for the vehicle. So with this residual energy after the collision, whatever is there, that is the energy that has been transferred to the occupant present in the vehicle. So like that, you can look at in every aspect. So pedestrian safety protection, if you take, you would see that you have your requirement of your vehicle frontal portion, and there should be an instrument panel, and you see what do you mean by impact. So what are the standards associated with that? And there is some steering column. So the steering column should also have a material such that it can absorb energy, and there will be it is going to crush and remove the energy. So any way part component of your vehicle should get deformed, and then it should take away the energy, so that the energy which is transferred to the occupant would be minimized. So the severity can be prevented by the restraints present in the vehicle. So similarly, you can see the headrest and the roof. If we take rollover safety, if we are looking at, so the roof should not crush and the cabin volume should not go away. So the roof should be so stiff enough that the integrity of your vehicle cabin is ensured. So similarly, the rear impact, you see, you have like in the frontal portion of your vehicle, you have energy absorbing material. You would also have the material made at the rear part also should take the energy. And you can see there are seat belts for the driver, occupant, and then rear seat passengers, all are present. So this is all something, this picture is to bring in how the vehicle has been developed because of the mandate that comes from Federal Motor Vehicle Safety Standards is what is witnessed, right? So you will have such an idea. So if you have to, how do you refer this figure? And this is, if you have to go for roof crash resistance, that is 216. So that is important during rollover safety. So you can see here rollover addition to 216, you also have other thing, but this is going to be predominant, right? So this is an idea which is brought in for the vehicle development. And you see what are crash tests. So crash tests are the guiding the vehicle with the required impact velocity hitting the rigid barrier or deformable barrier. So you see in this figure, this crashworthiness test for government star rating. So the star safety rating system for new model car and trucks, formerly known as new car assessment program. So that is what we were seeing like this. So it was started in 1970s in US, and in our country we had this new car assessment program called Bharat Safety Program. On 2017 we had implemented. We have different agencies like ARA is one part of it. And you see also here side impact test where your vehicle is held and then this barrier is been forced to hit on it. So what is to be noted in this is that the environment of crash test. So this environment is having the instrumentation, high-speed cameras, and your vehicle is completely instrumented. You would have dummies placed inside the vehicle, and you see them instrumented, and you see the responses measured in various parts of a human dummy that would reflect what would be the severity that would be faced by the occupant, and you would be able to calculate severity index. So I say these terms, but we will go ahead in our lectures. How are they calculated and so on. That all we will see them in detail later. And you can see here on this side, there is a test called the sled test. This sled test is what is something is predicting the response that is experienced by the driver or occupant. Though though they have been restrained with the seat belt restraint, how the kinematics of this person during the crash impulse is being provided. Crash impulse is sudden deceleration time history because of collision, and that would be in a very fraction of milliseconds it would take place. And such kind of input is given to the sled. Then how these dummies are going to respond in a laboratory separately can be done. So that this would additionally help us to develop an ergonomic aspect design of the seat so that the injury index can be reduced. So such kind of tests are carried out. So I just have put some sample crash tests. You also have center pole test. So when you see here, it is a frontal collision, full frontal collision on a rigid barrier. So you also have offset collision. So most of the time, real time scenario, vehicle when they try to overtake, there is a problem of offset collision with the front vehicle. So in such cases, how it is behaved. So you have different counts of crash tests. So here I just have sample to have an idea. If you go to Google and put their crash test and see the images, it is so much you'll get. Right? You can see different tests, and there are videos. You can just go through them. How are they conducted? So in fraction of seconds, it said. So you can see that videos and feel how this tests are carried out, right? And see, there are new car assessment program, which I was telling is 1978 was the first new car assessment program conducted by United States. Whereas you could see here there are many other countries. They also do their own new car assessment program for the new vehicles which are manufactured in the country. So like that, if you look at, we have Bharat New Vehicle Safety Assessment Program. And this is started in 2017. It is still going on to realize its complete establishment, right? So what is this Bharat Safety New Vehicle Safety Assessment Program? So you see that it's because it's been proposed by New Car Assessment Program for India. Cars sold in country will be assigned by star rating based on their safety performance. How are the safety performance are evaluated? Those safety performance are evaluated based on this standard test where AR AI has got these test facilities are mentioned. You can go through the website and you'd see these facilities, and then specification of these test facilities, right? And we have this program, BNVSAP, is from NATRIP. So NATRIP is what is that important agency like NATSHA. You have this NATRIP, National Automotive Testing and R&D Infrastructure Project. So under that we have this program, and this program has been conducted by ARAI. And these are the test facilities: frontal offset testing at 64 kilometers per hour proposed. So you see this ARI facilities has got not FMVSS regulations, it has got Euro norms regulations. So what are the points that are used for making an assessment is the points would be awarded on the car to the car based on the safety features in the car, like ABS, how ABS is working, seat belt reminders, child lock, and electronic stability control. So these are the aspects that are investigated during collision in this program. And if you look at why this is given more attention in our countries, because of these fatality rates. So India has seen more road deaths per year, more than any other nation since 2006. We have more of fatality, and annually around 230,000 members died. So this is what is that pressure, so that no, we our country also, we have this new car assessment program to be conducted. So the basic difference between US new car assessment program and India assessment program is with the collision speeds. So you see here, collision speed in NHTSA guidelines is 64.3 kilometers per hour, that is 40 miles per hour. Whereas here we follow Euro NCAP with 64 kilometers per hour frontal impact test, which is an average speed in India of the vehicles. So the speeds are decided based on that. And crash test facilities are being set up and regularly updated on this site called NATRIP. So NATRIP site, you can officially go and see what is the current status of our own vehicle safety assessment program. So like that for every country, what is that there? So if you go through that, that's quite interesting. And you can also do documentation. One can take up such work as J component work and see this program guidelines, how the tests are conducted, test environment. So you develop your knowledge in that, and that would also be one of the topic for your J component assessment. And when you come to vehicle collision models, why do we have to have a vehicle collision models? To carry out such a crash test facilities required, and that would be possible by the government agencies. Also, you can have by OEMs for that test, but however, they do have the test facility. Finally, the authority who is going to approve the vehicle for its safety performance during crash is these government agencies like ARA in our country. So most of the OEMs, other vehicle manufacturers do have their laboratory set up for component level testing, even for full car level testing, for doing the test for internal purpose before taking that for the certification. They do have, on the other hand, simulation facilities. And when you look at the simulation facilities, the vehicle collision models are quite interesting models. Many researchers have published articles, and people do use their mathematical modeling for assessment of this crashworthiness. So if you look at, we will go through the vehicle collision models during our lecture. We have one separate module for that. We will see them in detail. I just have put here to have a feel of what is it. So we can have a linear impulse and momentum and energy principle from mechanics fundamentals. On the left, whatever the two vehicles colliding each other. Correct. So the target vehicle is going ahead, and then bullet vehicle is going to hit on that from the rear. So when they are hitting, and how are the energy getting transferred, and what would be the scenario after the collision for both the vehicle? What separation velocity they go on. So these velocities are really to calculate your kinetic energy that's present in the vehicle. So the energy will not be conserved along the line of impact. The energy what is being left is what is the energy that go into attack the occupants, and that is where the role of restraints, seat belts, or your airbags should be so sensitive to react immediately before the motion of the occupant hitting the steering column and so on. So it has to be so readily to deploy so that it can safeguard, the airbags can safeguard the head injury of a driver or other occupants, whether it is frontal or side collisions. So if we will have such a Newton-Euler equation based collision models, on one side we will study, on the other side we will look at LMS, that is lump to mass spring vehicle model. So you can see here this lump to mass spring vehicle model. Vehicle has got different masses. So M1 here is the body which is to be not going to deform. M2 is what is here referring to your engine mass. So you see other F1 to F8, which all are referring to different parts of the vehicle in the frontal zone, and their forces that are involved in that. So these forces are realized in your model by means of the stiffnesses of those models. So that is where the stiffnesses are estimated through component testing in the laboratory. So an individual component stiffness values are used here so that you would know what would be these forces. So finally, it is kind of a vibration model where the excitation is not a simple excitation like sinusoidal excitation and so on. Rather, it will be a crash pulse. So you would give an impact as an input, and then you see what would be the responses at different masses, and that would help you to quantify crashworthiness scenario. So we will see such models in our course. We also have a module for pedestrian safety and ergonomics requirement in your vehicle. So if you Google it and you get many images, I just have taken this image where for pedestrian safety, there are government regulations to follow the rules. So you have to follow the signs, and whenever you are allowed to cross the road, you are supposed to cross, and there would be timing. So we see that in a traffic scenario in office hours, how people, pedestrians are transiting on the highways or on the urban roads surfaces. One on this side for the safety measures. On the other side, the vehicle ergonomics are very important. So the driver seating posture, the driver anthropometry is what is important. So anthropometry is how the dimensions of your the driver physical dimensions and the vehicle dimensions all to be arranged so that he would be so comfortable to have a necessary action to avoid the hitting of a pedestrian. So if the driver comfort is not there, if there is no appropriate ergonomics of your vehicle for that, then there will be a scenario that the safety of pedestrian would be question mark. So you have some of the studies, aspects of pedestrian safety that we will be studying in detail. And these are the points that we will be focusing on such studies, right, which is listed down here. So if you look at pedestrian safety and ergonomics, you see the seating posture of the driver. You can see there are 5 here. So let's see one by one and how that would be useful for reducing the or ensuring the safety of pedestrian, right? So here you can see that the steering column should be adjustable. So adjust the steering wheel forward or backward so you can comfortably reach it without impending leg clearance. So you have to have flexibility. So our steering can be adjustable, that you can see steering wheel column can be adjustable. Then similarly you have this headrest, so that can be adjustable. Adjust the headrest so it supports the head in case of an accident but does not cause the head to protrude forward. So the headrest could save the head injury. And adjust the backrest so to a recline. So this backrest angle should be 100 to 110 degrees. So your entire back should be supported. There should be absolute support. So you can't like, no, I sit now without leaning back. I just look at the monitor and I speak. But you can't afford to do that for a longer time driving in our vehicle. So we should have our back is completely supported so that you would no, be very comfortable there. And raise the seat as high as comfortable to improve vision and angle so that the thighs are supported along with the length of the cushion. So you could be able to adjust your height of the seat. So adjust the seat so you can fully depress the pedals and that your legs have adequate clearance under the steering wheel. So the seat location should be such that, so you can see in every vehicle you would be able to make this all adjustment in the seat, and you should only start driving once you are comfortably seated. So this ergonomic design will vary from person to person because of their physical nature. So you should have accordingly that should be adjustable. So that's what you would see. What is that ergonomic studies that go in your vehicle. So if these ergonomics are provided to the driver, that would ensure not only the safety of occupants and vehicle, also ensure the pedestrian safety. And you can put these all again. See, I have just put these slides from Google. I have taken many pictures and I have just organized for today's lecture so that it can take an overview of our syllabus, right? So you can see what are these crashworthiness restraint technologies. So you have in a vehicle, these all are there. So in an advanced vehicle, you see, you have an automatic door locks. So once you start, it ensures that your doors are locked. So at any point of time, especially during collision, your doors won't be open and you won't be thrown out. So that's very, very important. So automatic door locks are important. Driver and passenger front airbags dual level. So earlier it was only for driver. Now it's made mandatory. The front seaters compulsorily should have an airbag. So your airbag could deploy at the time of unavoidable situation. And you can also see the passenger sensing system. So this passenger sensing system would be useful for to see the surrounding environment of your vehicle. And you have here, see the rollover capable head cushion airbag. So airbags are not only comes from front, also you have on the side of your vehicle, so that during side impact the airbags will deploy. And you see on this top figure, you have the belts are the important restraint system. So as soon as you get in your vehicle, first thing what you have to do is you have to put your seat belts, and then you should start your vehicle. So this lap and shoulder seat safety belts are very important, and then belt comfort guide. So these are pre-tensioner belts, right? So it should be, and the energy management system. So these are all already now available in the vehicle, right? And you also have knee airbags. So in a critical situation, the knee also to be protected. Otherwise, what would happen if knee get injury and the vehicle is in high speeds, and it would again cause worst scenario of rollover and so on. So these are all some of the restraint technologies that are present in the vehicle safety system. So we will study them in more detail, how these are designed, how do you decide these restraints development, all we will see them in detail. So you have a separate module for vehicle safety systems study alone. And this safety systems we see, they can be grouped as passive and active safety systems. So whatever that you see in these slides, all are passive safety systems. Again, another interesting slide, I got it for vehicle safety system that has got numerous things here, right? You can just go through in a cyclic manner to look at them. So energy absorbing bumper mounts are there in the front, and front crumble zone. So you have this panel all would crumble, and they do not rebound. So it is not an elastic deformation. This crumble, which is a plastic deformation, and they do not get back. So that means it is eating away the energy during the collision, and the kinetic energy which is transferred to the occupant, the driver, is very less. So that energy is what is the rebound energy we call, where with that same velocity, the driver would be thrown forward during the collision. And as he is being thrown forward, it should not hit on the steering. So the deployment of airbag protect completely. It make securing the occupant, though there is a seat belt is present. In case the seat belt is not there, even this is deployed, and you would be hitting on the steering column. So the first in hand, you have this airbag and igniter, and you have additionally this front and rear lap shoulder safety belts. So you can see at the rear there is a kid, and you have the seat belts. So we normally avoid seat belts at the rear, but it is very, very important that the rear occupant also should wear the seat belts, right? And you can see similarly padded instrument panel here, and laminated windshield. So this laminated windshield is to avoid glare. No, you have a good vision ahead, and side airbags are present. There is a diagnostic module, so it could diagnose any kind of expected unfortunate event. Then no, it would see, it will give. See, you start your vehicle, you see that your all the systems, safety systems are working fine or not. You see, in case your airbag is not working, it will give you the warning signal. You do not put your seat belt, it will give you this warning that you are not wore. So such kind of diagnostic modules are there that will give the appropriate warning for the drivers. And to avoid this rollover and the integrity of the cabin, you could see in this figure, in the front as well as in the rear, there is a rear crumble zones. So this only get crumbled. We see during collision, the entire cabin volume is not changed, and it is restrained, which is preserved. It is preserved. And the occupant inside are not supported by seat belts and restraint system. that is again going to be very horrible. And that is why your vehicle crashworthiness or the assessment is tested based on the functioning of this restraint system and your airbag deployment all. So that all would be observed through high-speed cameras during collision. Is it then you can see every stills, and then is it really deployed the required time? Is the person protected? All can be later documented and can be used further for the assessment. So like that you have, and you see this roof structure again. It will be a high strength steel safety cage surrounding the passenger, so that during rollover condition, the stiffness of the roof and the floor all would ensure the safety. Head restraints, always you should have back support for the head. So these are all some of the safety aspects that in vehicle it goes. So how every element is designed, what are the critical points? You can more elaborate based on our lectures ahead, right? And again, I just have put this to put it in a simple thing, important aspects. You have this crumble zone in front as well as in rear, and you have rear seat belts, and you have front seat belts, and you have side impact bars, and also you have airbags on side and airbags in the front. That is not appearing here, airbags inside. So this is a simple passive safety system present in the vehicle. So that's exactly what is there in this slide. You have pre-tension seat belts, airbags, and deformation zones. So these are the three important passive safety systems present in the vehicle, and that protects the occupants of a vehicle and other road users if the crash occurs. Reduce the impact of an accident or the level of the injury. Mitigate the consequences of an accident during and after the impact. So these passive safety systems are mandated, and that has to be present in all the vehicle. Additionally, what are the other safety systems present other than this are called active safety systems that you can see here. What are those? So this active safety system that give the driver more control in a dangerous situation. So driver could have more control to safeguard the vehicle, right? So you can see here there are monitoring sensors. So the constantly monitor the performance and surrounding of the vehicle. So you have sensor technology. You could see this autonomous vehicle all. So the high-end vehicles, you have this so that it would always monitor what is happening around the surrounding of the vehicle. It can prevent accident from happening altogether or actively help the driver to reduce the impact, avoid or mitigate an accident pre-impact, so before it happens. So that's all are the advantage of control system and advent of advanced electronics. So if you see this active safety system means like whatever we have studied, anti-lock brake system, electronic stability control, autonomous emergency braking, and lane departure warning. There was a project done by a group in last time using CarSim software. So these are all something active safety measures addition to passive safety systems present in the vehicle. And we will have another module on injury mechanisms. So what are these injury mechanisms confined to the vehicle crash is what we have to see. So though we have these restraints, those restraints are controlling the injury. It's minimizing the injury. So what would be the injury, how the severity of injury understanding is also required. You have many articles present in medical journals. I have many samples downloaded. So if you are working on this understanding of injury mechanisms and design aspects that go into restraints, you can think of taking that as also J component work. So if you look at, there are two columns of this table. So injury mechanism on the left and then related injuries on the right. So related injury means what all, how the injury is quantified. It is quantified by the soft tissues. What are the damages that happens to the tissue, abdominal wall musculature. So we need to understand the anatomy of our human body, and then what are the different parts of our body get injured. So neck injury is what is very common in collision, and then spinal damage, and thoracic, that is rib and costal cartilage fractures. So it's all involved fractures of soft tissues or bones. And thoracic injury is confined to internal organs. So you have one paper where I could see that what would happen to a torn heart. So they have shown that in postmortem after the injury, the person fatality, they have taken and shown. So there are witness how severe injuries that one can undergo during the scenarios of collision. So that is all available from literature. We will also see them in detail later. Then it would also attack pelvic. So there can be bladder rupture because of that. And there are vascular subclavian. So you can have different. So these are all related to heart. So you have, these are all common for all the injury mechanisms. So if seat belt related injuries are there, you have such things, and you have steering wheel and windshield related injuries. So steering wheel and windshield related injuries, supposing the crash and the airbag deployment is failed, so the injury is what? So that is what related to that. So you have steering column should also have some crumbling material, so that can take away the energy. If that is not present, what would be the severity of this? So these are all some common injuries, and their severity depends upon what are the restraint system in the vehicle and what is the due mechanism. So that is what is one module that we have to study and understand. And you have this dashboard related injuries. See, hip dislocation that can happen, knee injuries can happen, and then floorboard related injury. So from floor, what would happen is this. That's all given here. So let's go through later. I would upload this and you can read it. And side impact injuries, again, what will happen to the different organs of our human driver during side impact injuries. So these are all something that we have to focus and understand clearly. And we have one module, introduction to test dummies present in the vehicle. So there are development of these dummies. So early dummy may not have resembled as it is a human dummy, and today you have dummies developed which can completely replicate the human behavior. So you have hybrid 2, hybrid 3 dummy families, and this CRABI. So what is CRABI? CRABI is referred to restrain airbag deployment. So it's related to airbag when it is deployed, is it protecting or not? Child restraint airbag restraints. So that is what is that. So you can see here there is a child dummy, and you have dummies for side impact, especially made. And if you put crash test dummies and look at Google images, you get plenty. You get plenty of resource materials. So what is that the world most resembling no best human dummy that is currently available till its initial dummies are used. So this dummies purpose present in the crash test is to understand the dynamic behavior of occupant, and these dummies also do carry the required sensors to understand to estimate the severities. So how these severities are quantified, what are the numbers, values that are go with this, all we will study in this module. So this is another last module of the course that you'll see. So this entire course content, module 1 to 8 is given with these titles. We had a samples of for each one of them, and we will go down, go and get into details in our upcoming lectures. And this course is designed with the course objective as follows: to gain the basic knowledge about vehicle crashworthiness, to help the students to identify the various testing regulations for vehicle crashworthiness, to assist the students to know about vehicle collision models, to broaden the knowledge about the pedestrian safety, to study the fundamentals of vehicle safety systems. So these are all the objective with which this course is designed. And upon successful completion of this course, the student will be able to acquire and analyze the various testing procedures of vehicle crashworthiness. So you would have a knowledge of different vehicle testing and the test procedures. So we have to work, and my delivery would focus on making you to get these skills. That's what I would keep in mind and prepare my lectures from the textbooks to deliver to you. And student would be able to characterize the various vehicle crashworthiness mechanisms. One student can develop a vehicle safety system for modern requirements, to use various injury mechanisms for evaluating vehicle crashworthiness. And student will be able to apply the dummies for different crash tests. So which crash test, which type of dummies are important? What do you mean by dummy harmonization? There are many aspects. There are a lot of things. So we will get into specific details during our upcoming lectures. So with that note, I would stop today's class. Before that, let me just put this slide, and this would be for J component. So you have the following topics as suggested. There are 6 topics that I will take care of the content of the syllabus, and there are many articles, research papers are available on these 6 topics. I downloaded many of them, so you can choose any one of this or your own interest, but that should confine related to the course content what we have discussed today. So this I would upload in MS Teams after the lecture hour. You can go through it. So we will have similar that what we have followed during vehicle dynamics, J component assessment, same way. So evaluation procedure is there is a 0th review. As time is not there, I expect that you work on this evening and tomorrow, and please come out with this initial report and selection of group members. So maximum 3 members can be there. Since it is a smaller class, I would recommend 2 sufficient, but still you want to make it 3 members, problem. So, but not more. So we will have in our class maybe maximum of 5 groups, or at the maximum 6 groups, right? If 2 are there in a group like that. So it will not go beyond 6 groups. I wanted that group, and then your topic selection, what is the motivation? So just to give an idea, how did you do for the vehicle dynamics course? So same way you prepare this and do submit it by 30th June, that is day after. I should have clarity of members of the groups, right? And then important dates, review 1, it's a oral presentation. We will have that is in this week, 19th to 23rd July. So I don't require all the days because of less groups. We will have any one convenient date which will not disturb you learning other courses or other course requirement you will be working. So in this week, July 19th to 23rd, just before your midterm test, you would be having your oral presentation to exhibit your progress in your J component. And review 2, which is of 30 marks weightage, would be on 4th August. So that is no review. Instead, you will have only the draft submission. I'll go through that, and then we will have review 3. You would submit the deadline 11th August. You'll have your final presentation similar to that, and during 9th to 13th. The 13th is however, the last instructional day of the semester. You would submit your report. So you would have similarly one author will present, the others should have questions to ask. It's all just kind of preparing yourself to present clearly what you have done during the J component, right? They need to go, so there should not be any doubts of these important dates. See, please try to adhere to these dates, and you also know the important dates for your quizzes. 14th July, 9th August, you have two quizzes. And 11th August is the deadline, last lecture day for your DA, which is this class notes, understanding plus your self preparation notes. So I have not given more information. So this has given you an idea of what all that you can further explore. So each slide of mine, if you are properly understanding and you require, you refer back textbook or the internet resources and make your own notes, and that would be your DA. So if you are doing this DA excellent, and that would also take care of your J component. So it's all collective exhibiting your learning outcomes of this course. So that's very important. And these are all the rubrics for J component, theory component, and proceedings and guideline for your J component 1 credit assessment. So if you have any doubts, you can ask me at this point of time. Otherwise, I will end the lecture, and we will meet again on 9 o'clock on Wednesday, on 30th. Right? Do you have any doubts that you want to ask? Please go ahead. All 11 of you are present. So, you have any questions? Shivam Chawla?
Yes, sir.
You have anything to ask?
No, sir, it's fine.
It's clear, right? So,
Yeah.
what was the today's task is that the complete orientation of the course, clarity of our upcoming lectures, our activities for the semester, and kind of motivation, what all that we are going to study in detail in our course. So that is I thought of sharing with you to give a motivation for learning this course. I hope I did my job, and you are all very much interested to go ahead with this learning of this course. So with that note, I'll stop today's class if there are no more questions. And you can go. I have downloaded your attendance.